Hey everyone, my name is Yiyu Chen. I'm a building performance engineer at Zero Envy. In this video, I wanted to show you how to create an energy model geometry in Autodesk Revit. There are so many ways you can use to create the geometry. You can use other tools like SketchUp. You can also directly create the geometry in an energy modeling software. But here at Zero Envy, our go-to approach is to use Revit. We found it's really efficient and it's a big time saver, especially when it comes to bigger projects. So we just want to share that knowledge. And in this video, I'm just going to walk you through a quick demo to show you guys all the steps and what it takes to complete a model in Revit. And then I hope you guys can have a better idea on how the entire workflow looks like. So yeah, let's jump into it. So the first step is to link an architectural Revit model as a background in our blank Revit file. So the whole idea here is that we want to have this background and we can trace it. It is really hard to directly export an architectural Revit model to a gbXML file. Usually you will just run into a ton of errors. So we just wanted to have this background and we can trace it to create a cleaner geometry that we can export to a gbXML file successfully. So in order to do that, you will go to Insert and click on Link Revit and pick the file you want to import and open. Usually it takes a second to load. Once the model is loaded, you can look at it. So I'm going to go to the 3D view just to see if it shows up correctly for me. Looks like it's here. So it's two high-rise residential towers, and my demo, I'm just going to be focusing on one of them. So what I do is usually I will just turn on the section box in the 3D view so I can just focus on the building that I wanted to work on. So once you have the section box, I can adjust the scope. So I'm going to just crop out everything that I don't need. Okay, so this should give me what I want. So yeah, you can rotate around and see how the geometry looks. So it's a pretty complicated building. And the next thing is basically to set up the levels. So we can then go onto each level to create exterior walls, interior partitions, and etc. So in order to create levels, you can go to the elevation view. So I have 4 elevation views created already, and I was just going to go to one of them. So all these levels here are from the architectural model. What I'm going to do is I will just create the same thing following these level numbers. So go to architecture and click on level. So we can randomly just place one level here. And I will update its name to match the actual name of this level. I'll just call it level 1. For the height, you can actually see what the height is here for level 1, and I will adjust it to make sure it match the actual model. So that's your level 1. And then it's going to be a little bit repetitive, and you will create level 2 and make sure, match the level 2 height as well. I'm just going to create the rest and come back. So I just created all the levels. As you can see, start from level 1 all the way up to level 28. I skipped the underground parking levels because it's the same method and it doesn't add more value to this video. So I'm just going to focus on the above ground floors. So yeah, the next step would be go into each level and start creating walls. So I will go to level 1. So you can go here and pick level 1. What you're seeing here is the architectural background. So this is a little confusing. It's not exactly the plan that I needed to create construction. So we need to pick a floor plan that we can work with. Here you can on keyboard hit VG to open the visibility and graphic settings. Over here in Revit links, you can see this is the link we have been using. And under display settings, you can open it, check my link view. So this will allow you to pick a view that you want to use as the background. Sometimes it takes a little work to find out which one is the one we needed, because sometimes one view can be clear, but maybe it doesn't have room names. One view can have all the room names, but maybe the plan is just not clear. For me, I know it's North Level 1 is the one I wanted, so I will choose this one and hit OK. And over here, you can make it underlay, so the background is going to show up as a faded or a halftone. Click on OK. So you can see this has changed to underlay, and also you can notice like the room names are showing up now. So this is the plan I'm going to work with to create my geometry. All right, so the next step is to create external walls. One thing I forgot to mention is that we have a Revit template in which we have created a bunch of envelope components. Every time when we start a new model, we will start from the template and turn that into a project. And then we can just pick the components and from there and start creating the model. If you go to wall category, you can see we have created a few wall types here, and we have also color coded them so they can stand out once you turn the color on. And if you want to change the properties of these walls, you can open edit type and you can do a bunch of things here. You can update its name. You can change the thickness if you want, which is pretty handy. Basically, once you have created all these components and just make it a template, and every time you can just start from the template and keep reusing it. So yeah, I'm gonna start from exterior wall. And so once you pick the component, the other thing to make sure is you're setting up these constraints properly. The base constraint for our wall will be level 1, of course. And then top constraint, when you first start, it's going to be like a random number. So you want to make sure you're picking the right level. We want our wall to go from level 1 to level 2. So this is what we need. And it's going to show you the height of your wall, which is 13 feet. And that's based on like all the levels we set up in the first step. And you can also give it a top offset if you want, but this is all I need. So I'm gonna start placing the walls. So one thing I wanted to quickly mention here is that we typically follow the center line of the walls based on the architectural background. I guess people have different opinions here. You can follow the interior wall, you can follow the interior surface, or you can follow the exterior surface. And I guess the difference is that depending on which approach you choose, it will have an impact on your floor area in the energy model. Because when you're doing a takeoff on the PDF, area takeoff on the PDF, you typically use the interior surface of the wall, right? But the energy model is going to pick the center line and consider that as where the wall is. Let's say if you also follow the center line and the wall thickness is 6 inches, and you will just end up having like a 3 inches increase on each side, and then eventually you will have a larger floor area for that room. I guess just wanted to bring up this point that just be mindful that depending on what approach you choose, it's going to have an impact on the floor area. So I will just keep going to finish this floor. All right, so the exterior walls on level 1 are all created. So now if you wanted to do a quick check, you can actually go to the 3D view to see how they look. You can see the architectural background is still there. Hit VG and you can turn off its visibility and click on OK. So what's left is what I have just created, all the exterior walls on level 1. So they look good to me, and it will also be nice to compare your components against the architectural model to see if they're lining up properly. So we can just zoom in and see how the model are lining up with the architectural ones. So I'm going to go to level 2. Here again, we want to pick a good view to work with. Hit VG on the keyboard. We can pick a view. So I want to select this north level 2. So I'll just pick it and also use underlay. so it can show up nice and clean. So this is the view I'm going to work with to create exterior walls on level 2. So I will keep going and to finish the next few levels and come back when I need to work on the residential levels. Okay, so I have created all the exterior walls all the way to level 12. And this is where I start seeing there are many repeated floors, typical floors. So this is where we can use a trick in Revit to quickly build typical floors in one step. And before doing that, we can quickly examine the model, how it looks like right now. So this is what I have so far. As you can see, it's a pretty complicated shell, and there aren't that many typical floors all the way up to this point. So it was a little bit of a manual work, but from here, we can pick up the speed a little bit. So let's go to level 12. What I will do is you can select one of the exterior walls and right click on it and select all instances visible in the view. So it's going to select all the exterior walls on this floor. And then we want to copy and paste all these to level 15, 16, and 17. This building doesn't have level 13 and 14, so there are only 3 levels that are the same as level 12. And starting from level 18, it's a different footprint, and I think it repeats again based on level 18. But let's now just copy paste all these walls to level 15, 16, and 17. So we have selected everything here. You can go to copy to clipboard and do paste. Select this option, aligned to selected levels. And then we will pick our target floors, which is 15, 16, and 17. Okay, so now the work is done, but we can't see anything here because we're still on level 12. But if you go to level 15, you can see how these are created, and they're created at the correct location. And now if you go to the 3D view, you can examine how it looks like. So you can see how these 3 levels are newly created. Initially, it was just this level 12. If you go back to level 15, you can also click on one of the exterior walls and see the constraints. So the base constraint is level 15 and it goes up to level 16, and that's also correct. Yeah, that's how we can create a multiple floors in one step. A quick note here. So we always want to make sure all the walls are perfectly stacked. Doesn't matter if it's exterior walls or interior partitions, we always want to make sure. For example, if we have 2 walls, one on level 1 and one on level 2, and if the wall on level 2 is right on top of the other wall on level 1, we want to make sure they're perfectly stacked. If they're slightly offset, chances are once you export this model to a gbXML file and into an energy modeling software, it's going to turn into a geometry issue, and they're probably going to be detected as small surface or slivers, and that can potentially lead to a simulation problem. So we wanted to avoid that as much as we can when we are creating the Revit model. So just to show you guys what I was talking about, so I'm on level 2 right now. I'm just gonna turn off the architectural background, and you can actually see level 1 from this view. So go to underlay and set the base level to level 1, and then you can see everything that's on level 1 that you have created. So everything looks okay, except when you zoom into this part, you can see this wall on level 2 is not lining up perfectly with the one on level 1. So that's an issue and can lead to a small surface problem in the energy model. And what we will do here is quite simple. You will just move this wall to make sure it's lining up perfectly with the one below, and that should solve the issue. Okay, so I have finished all the exterior walls. Now you can see this model looks more like the actual architectural model. We can also turn on the background to check. So you can rotate around and see if everything is matching. And the next step from here, so my workflow would be start working on the interior partitions. And again, it will just be the same process. You will be starting from level 1 and start working on the interior partitions using the same approach. I'm just gonna directly jump to one of the residential floors to show you how to complete a floor. And basically, instead of using exterior walls, we are gonna pick our interior wall to create interior partitions. Over here, we also want to make sure the constraints are set up properly. So it should start from level 12 and the next level is 15. And then you can start working on the creating the interior partitions. So all the interior partitions are created on this floor. And as you can see, we have a number of multiple units, residential units on this floor. There are different types. I think this is a studio, and you have some 2B units and 1B unit, and there's a common corridor and elevator shaft and 2 stairwells. And I think this is storage, and you have a mechanical shaft as well. So I'm also modeling one zone per residential unit. The next thing, we can use the same approach because we know level 12, 15, 16, 17, they're all typical floors. So we can do the same thing as we did with the exterior walls. We can just copy all the interior partitions on this floor to the next 3 levels. So we can zoom in to pick one of the interior partitions and again, select all instances visible in the view. It's going to pick all the interior partitions for you, and then we will just do copy and paste to the selected levels. So I'll pick 15, 16, and 17. And it's down. And if you go to level 15, you can see how these walls are created, and it's exactly at where they need to be. Same thing on level 16 and 17. Okay, so I'm not going to finish all the interior partitions on every level because that's going to take a long time. I'm gonna just directly go to the next step, which is to create floors and roofs. Before doing that, let's quickly go to the 3D view to examine what we have just created. So these are the interior partitions we just did. Actually, you can also reduce the size of your section box so you can just focus on those levels. So they all look good to me. And yeah, we can then move on to the next step. So I'm gonna change it back and go to level 1. Over here, we can start working on the floors. I would like to turn off the architectural background so my components can show up more clearly. Select floor, and over here, since we're using a template and we already have 2 types of floors created, we will just pick one to use it. I'm going to pick this exterior floor. And over here, also make sure the level is correct. We are on level 1 and we are creating the floor on level 1. And over here, I wanted to use this pick lines method, which is a little more efficient. So we can just pick the center lines of the walls we created to form the boundary lines. So once you have selected all the center lines, you can go ahead and click on this edit, finish edit mode. The floor is going to be created. If you go back to the 3D view, you can see our level 1 now has got a floor. So you will just be doing the same thing for the rest of the levels. And again, use the same principle. If there are typical levels, you can just create floor for one of the levels and copy paste it to the remaining ones, which should be pretty efficient. That's all about a floor. Now I want to talk about a roof. For the roof, I wanted to focus on the top 2 levels, level 27 and 28. So level 28 is the top level, so we're going to create a roof here. For level 27, because level 28 has a smaller footprint and all this area is going to be a roof as well, we will start with level 28. So for creating a roof on level 28, we actually need to be on the next level, which is, basically the roof level. So over here, I have turned on the underlay to show level 28. And all these are the exterior walls on level 28, and which is what we will be using to create a roof. So go to roof and pick a roof component. Also make sure the settings are appropriate. We will be working on level roof we also have a base offset. So there is a reason that we do this. So when you place a roof, the bottom surface of the roof is going to be at the same level of the wall, the top of the wall. And once you import the model into the energy modeling software, I think the software is going to recognize the top surface of the roof as where the roof is. So that means there will be a gap depending on how thick the roof is. In our case, 6 inches. You will have like a 6 inches gap between the top of the wall and the end of the roof. So my experience is that in the software, in the modeling software, it will create a shading surface that's floating on top of level 28, which is a geometry issue. And so one fix is basically give a 6 inches offset. So the top surface of the roof in Revit is going to be at the same level as the top of the wall. I hope that makes sense, but I also can show you guys what I mean. Let me also use the same method to create a roof, which is to pick center lines. So we just created all the boundaries, and now you can just check this one and finish it. And then we can see the roof is created for level 28. And if you zoom in, you can see the top of the roof is at the same level as the top of the wall. If we don't do the 6 inches offset, you can see how the top surface will be floating, and so there will be a gap, and this top surface is going to become a shading element in the modeling software, and that's something we wanted to avoid. So for roof, we have always been applying a 6 inches offset, so that will fix that issue. Now I wanted to create a roof for level 27 as well. If you go to 28 to create a roof for 27, you will be looking at this view, and I have level 27 turned on as the underlay, so you can see all this area is going to be a roof. Again, we will do the same. Pick the roof component and use the Centerline method. So click on OK, and this roof is created. Now go to the 3D view again to check it out. So it looks great to me. So yeah, and this situation is happening a lot in this project. As you can see, this part is going to have a roof. There's a small roof here, and you have a roof here, and down below you have some big roofs to create, but it's all the same principle. So I think I've covered pretty much everything on the plans. Now let's turn to the elevations to create windows. Let's go back to the 3D view real quick to see how it looks. So you can see my exterior walls are kind of blocking the background, but you can still see like where the windows are. And if you click on the walls, you can actually see what's behind it. You can see the background. You can also just hide them, but this is good enough for what I wanted to show. So yeah, we want to be working on the plans to create windows, but it will be nice to also have elevations open on the side, and then we can reference it. So to do that, you can go to view and do this tile views, so you can have both elevations and plans opened side by side. We will be working on level 12 again. Over here in the elevation view, that would be this floor. So if you zoom in to this corner, which is basically this area, if you click on this, you can see that we have some windows here. So we have a fixed window over here, we have an operable window, I think, and then this is also a fixed window, and we have some spandrel panels down here. So to create a window, go to Window, and this is the list of the pre-created window components we have. And my go-to is Window Instance, which will allow you to change the dimension of the windows once they're placed in the model. So I also have a bunch of glazing types created here. The reason of doing this is because this project has so many different glazing types, and I wanted to capture it in Revit because it's going to take forever to do it in the energy model, because you just need to pick every single window and then assign construction to it. If we can do it in here in Revit, it's going to be much faster. So for each glazing type, if you go to Edit, I have selected a unique analytical construction. There's a list you can choose from, so this is pretty helpful. So you will basically create a bunch of glazing groups here in Revit. Once you import this model into the energy modeling software, those groups will stay, and you can just pick the groups and change their thermal properties of the glazing. To create the window, I'm gonna just pick one of those glazing types. I will just do the fixed division to create the first one over here. So if you zoom in and just place a window here, and you can see how it shows up on the elevation, and then you can just drag it to change its width. For the height, and you can change it. I know it's 9 feet, and also the seal height is 0, so it's going to go from bottom to top. And for the next window, I will pick the operable vision because it's an operable window, and you can do the same and adjust its size a little, location a little bit, and change its width. And also, I'm gonna keep 3 feet as the seal height and change the height to 6 feet. So that's this operable window. And then for the next one, you can actually drag this one over to create the next one and adjust its width to make sure it's at the correct location. And this one is actually a vision, fixed division as well. So I'm going to change it back. That's done. And now this wall has spandrel panels on it. So we will use doors. So there are different approaches on how to deal with spandrel panels. Our go-to approach is just use doors because I think it's pretty hard to like split a wall into multiple pieces and assign thermal constructions to them. The more straightforward way would be just using a door to represent spandrel panels, and you can create a unique construction for the door. So we will do that in Revit as well. So go to door, and I'm just going to pick this one, and then you can place a door here. It's intersecting with my windows now, but I can change its height to what it needs to be, and then you can adjust the width of the door. So this is the spandrel panel and the windows. I will go ahead and finish the rest on this floor and come back. So I have finished all the windows and the spandrel panels on level 12. So now again, if there are typical floors, you can just copy and paste them up. For example, let's just copy and paste the glazing. Select the one and select all the instances in the view, copy, and paste them up to these 3 floors. So they will show up, and you can do the same for the doors. Here we go. So the last thing I wanted to show is how to create shading elements, which we will be using roof to do that. Let me turn on the background real quick. As you can see, these are all balconies, but there are also shading elements for the level below, so we will need to create them. So I will just do one example. So let's do the sky, and that's on level 18. So we will go there. Basically, this part is where the shading is, and you need to have the architectural background on in order to see this. So let's pick the roof, and I'm just gonna start tracing it. So if we turn the background off, you can see our shading there. And at this point, you probably guessed what I want to do next. Here we go. We just created multiple shading elements. So we are finally at the final step, which is to create spaces. right now, let's say this geometry is complete. We have all the walls, roofs, floors, windows, and spandrel panels. Everything's down, but we still cannot export this model to a gbXML file yet because there are no spaces yet. In order to do that, let's go to one of the floors. Let's go to floor 12. So I have the architectural background on, and you can now see all the rooms and their names and room numbers. So to put spaces here, you will go to Analyze and click on Space, and also make sure the limits are correct. So we are starting from level 12. The room should end at level 15. There's no 13, 14, remember, for this building. And also we don't want to provide any offset. So this is good. And then you can start placing rooms. As you can see how it's recognizing all the interior partitions. You can just place them one by one, or I like to use this place spaces automatically. So it will just create all 12 spaces all at once. And then you can go ahead and change the name of your spaces to match the architectural naming. But that's pretty manual work. There's a quick trick to do here, which is to use this space naming function in Revit. So if you click on that, it will ask you how do you want it to match. You want to match both names and numbers, or names only, or numbers only. For this demo, I'm going to just pick this names only, and then I'm going to select this floor, and you can just see how these names are updated to match the architectural room name. I think I missed one room here, but you get the idea. Okay, so I will do the same thing real quick for next level. So yeah, pay attention to these limits because the first time they show up, it will be random. So that's good. Cool. So I just did 2 floors, and now final step, which is to basically do a check. So in our template, we have created a space schedule. If you go in there, it's gonna show you all the spaces you have in the model. And the way we set it up is that it's already grouping the spaces together based on levels. So we have level 12, level 15. I always come in here and check if everything's making sense. I check a few things. For example, all the spaces on level 12 should start from level 12. And also they should have the same upper limit. So go from 12 to 15 is what I want. So that's correct. Same thing for this level. Go from 15 to 16. Sometimes, you can accidentally set one room's upper limit to something else like 16, and then you will be easily identifying that here. Also, sometimes you probably didn't set up your limits properly before you place in the rooms, and there will be a bunch of limit offsets here, and you can see them clearly here, which you can then just remove them by overwrite them to 0 here. And also make sure the unbounded height for all the rooms on the same level are consistent in most cases. That will be the final check. All right, I think I have covered everything that I want to show in this demo. Obviously, I didn't finish that model because that's going to take a while. Instead, I've pulled up the original model that I worked on for this project, and I can quickly show you guys how to export this model to a gbXML file and an energy modeling software. So before exporting, stay in Analyze and go to Energy Settings all the way over here. Open it and click on this Edit, and then scroll all the way down to the bottom. Here, make sure this detailed elements is checked. The reason of doing this is because if you remember, I created a bunch of glazing types in this model and have assigned them to these windows. In order to make sure they stay when you export the model, we want to make sure the detailed elements checkbox is checked. So once that's done, the model is ready to be exported. So to do that, stay in the 3D view, go to File, click on Export to gbXML and use the second option. And this is the gbXML file rendering, and you can rotate around and to see how it looks. Also go to the Details tab, and you can see the list of your rooms here. If there's anything that's problematic, there will be a warning sign in front of the room. So you can click on that room and isolate it, see where it is and go back to the model to fix that. If everything looks good to you, you can click on Next to export to the gbXML file. So the model is exported. I've also opened IES Virtual Environment, which is the go-to energy modeling software here at Zero Envy. The interoperability between Revit and IES VE is really great. That's also part of the reason why we love this Revit to VE workflow. So if you're using VE as well, this is what you're going to do. Go to File, Import, BIM file. Select the file you want to import and open it. And it's going to take a while to load, and you can see it's going through all the rooms. And once the model is loaded, you can see all the rooms are here, and it's asking you what are the things we wanted to import into the model, into the software. We definitely need all the rooms, and we need all the shading elements, which is stored in this non-thermal spaces category. And go to Next. There are other things you can import as well, but for me, I just need the geometry. So I'm just going to click through and start and finish. So once the model is loaded, you can open this model viewer too to do a quick visual inspection and see how everything looks. So we have got all the shading elements in here. All the spandrel panels are imported. These are doors, and all the windows are here. So the model looks all right by looking at it. You can also go to Model It and Model Report. Select everything in Section A to generate a geometry check report. It's going to be in HTML format. So this is the report, and all these are different error categories. If there's anything wrong, it's going to show up in one of these sections, and it will tell you the name, a room name. You can either fix it in VE directly, or you can go to Revit and fix it here and export the model again. Basically go through the same process. So that's everything I want to show. I hope it's been helpful, and thanks for watching.